This video is operations on square roots. Basically, we're going to add, subtract, multiply, and multiply. Adding square roots. When you add square roots, it's kind of like adding like terms. You can think of the radicand sort of like an x. You could have 5x plus 4x, and you'd get 9x. So in order to add square roots, you have to have the same radicand. So this 3, the square root of 3, that has to be the same. It could be like a cubed root of 3, but it has to be the same. That 3 number has to be the same. And the index has to be the same. So you just go 5 plus 4 and get 9 root 3. This is the answer. This guy's the answer. Okay, next. Same thing with subtracting. You have to have the same radicand. So because this is the same, I just do 5 subtract 4, and I get 1 square root of 3. Which you don't really write that 1. This is usually the best answer to put. Alright, sometimes you try to add, and you can't really add square root of 8 and square root of 50 because they're not the same radicand. So you should simplify. So I simplified by making a factor tree. And this one simplified to 2 square root of 2, and this one simplified to 5 square root of 2. So now that they have the same radicand, they both have this square root of 2. You can add. So you just add 2 and 5 and get 7. Okay, this is a next one. You can't add these. You can't add 3 square root of 20 plus 8 square root of 45. So you simplify to see if you can. Well, it turned out when you simplified, you got the same radicand. So because I have the same radicand, I just add the coefficients, or the numbers in front. 6 plus 24 gave me 30 root 5. Doop. Multiplying square roots. So multiplying square roots, you just multiply. Because these are all square roots, you just do 2 times 7. And you get square root of 14. And if you could simplify, you would. But you can't. Square root of 14 is simplified all the way. So the next one I did square root of 3 times square root of 6, and I got square root of 18. But square root of 18 can be simplified. So you do a factor tree. And square root means a pair of 3's. A pair of 3's become one number and go out. So you write your answer as 3 square root 2. So here's one little harder one. Square root of 10 times square root of 30 gives me square root of 300. So you break it down and simplify square root of 300. When I get a pair, I know that is a square root, so I take the 10 out, and I'm left with this guy. He doesn't have a pair, so he has to stay in the radical. So this is the final answer for that one. Square root of 8 times square root of 20 gives me square root of 160, and then I simplify. I got these 4's, so 1 4 will come out, and 2, and I multiply 2 times 5, and that gives me the square root of 10. Then I did this one because it has variables. Square root of 10ab squared times square root of 2ab squared. So you just multiply 2 times 10 and get 20, a times a and get a squared, b squared times b squared and get b to the 4th. Then you have to simplify. So I did a factor tree. I got it down to 2 times 2 and 5 for 20, and an A, and 4 B's, B, 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 B. So then, when you simplify the square root, any pairs come out. So this pair became this 2. This pair became an A. And then there's a pair of B's and another pair of B's. And you write that as B times B, which is B squared. And then this root 5 doesn't have a pair, so it stays in. The next one, negative 4 times 9 is negative 36. Square root of 5 times square root of 4 is square root of 20. I break down square root of 20. I get a pair of 2's. I bring a 1 2 out. 2 times negative square root of 36 is negative 72, and the root 5 stays in. Last thing, just remember, anytime you have a square root times itself, you get square root of 9, which is 3. There's like a pattern here. Square root of 7 times square root of 7 is square root of 49, which is 7. Are you seeing the pattern? Square root of 6 times square root of 6 is square root of 36, which is 6. So the deal is a square root times itself just gives you that number. Square root of A times square root of A is square root of A squared, which is just A. All right. That is just leave it. This is called rationalizing the denominator. If you have 1 over a square root, the way that you get rid of the square root out of the denominator is you multiply it by itself, because that will give you the plain old 3. So it's okay to do this, because this is like multiplying by 1, and you can always multiply anything by 1. So this is sort of the trick for rationalizing the denominator. All right, that's the end of this video. Thanks for watching.